Hey everybody, it's Miss Peachy from your WCA Earth and Space Science. And what I'm going to do today is I'm just going to be showing you what you need to do for your next portfolio. So your next portfolio here is Unit 2, Lesson 4, Trends in Air Pressure. Your Unit 2 is on Weather and Climate. So for this portfolio, you're going to be doing a lab where you're going to see what happens with a different situation in air pressure. So there's a couple of things I kind of want to point out to you. So it starts off on slide 1 here. The lab itself is not gone through on slide 1, but there is some background information that you need to do. So first of all, let me kind of direct you to where you can find the student guide, the thing you're going to be turning in to me. You can download it here, but it's probably easiest to get it from our website. So I'm just going to open up our website here. And it takes a second here because my internet is just ridiculously slow from home here this week. What you're going to notice as you scroll down on the website, this is our Earth and Space Science website here, slowly loading. As you scroll down past the live lesson recordings, you're going to see a section on portfolios. And that first video is the one that I made for you on the Science Rocks graph that you had to do for your first portfolio. And there'll be a video here that we're recording right now. Your second portfolio is Trends in Air Pressure. And if I click and open this right here, that is going to open up the lab sheet that you need to do. So this is your lab sheet. You can scroll to the top so you can see it. So this first section, tasks 1 and task 2, those are just background information that you'll need to do. Now, the first thing you should probably do is you're going to it'll probably look like this when you first click on it. You're going to need to either download it to Microsoft Word, which will open on your computer, or you'll need to make a copy of this or open it up with Google Docs, open in Google Docs, which is what I did here. And once you've opened it in Google Docs, you can go to File and make a copy. And then you can put all of your work in the copy. You don't put the work in the original because it won't let you, so you do have to make a copy. Once you've done all your work, you're finished with the entire lab, then you'll want to go back to File and then download it as a Microsoft Word document, and that will save it to your computer. Go ahead and save it to your desktop, or if you have a science folder on your computer, save it to your science folder. And then when you put it in the Dropbox, you can upload that document to the Dropbox. So it will still be in Word, even if you don't have Word on your computer. If you have Word on your computer, then you can just go ahead and download it to start with and edit that one. Okay, so tasks 1 and 2 are background information. When you are in our lesson viewer, you will find the information needed by clicking on this link here, which brings you to a website, a PBS website by Nova, where it gives you lots of information. And if you read through this, it should give you the answers you need to complete the first part of that lab sheet for me. Okay, so the first part of that. Then you get to the second part, task 3, which is the lab part of the lab called Crush the Can. Now, this one you can do in your house if you want to, if you have the materials and your mom or dad give you permission to do this. You can do this on your own and make your observations from what you've done. If for some reason you can't do this at home, maybe you don't have the materials, or your mom and dad, say you can't use the stove when they're not around and stuff like that, then you should probably watch the video that I'm going to show you, and you can make your observations on the video. So these are all the instructions on how to do it on your own. All right, so what we're going to see is we need to look for a few things here while we watch the video, okay? I want you to observe while we're watching the video, what happens with the can as it's being heated on the burner. I want you to observe what happens when we turn the can upside down and place it into the cooler pan of water. And then we should make an observation about how much water is in the can at the end compared to how much was in the can at the beginning. So those are 3 pieces of data I want you to look for and observe during this video. All right, so here we have our video. I'm going to go ahead and press play. And then we are going to watch it. I will narrate kind of as we go rather than the people in the video, just so that they're not giving away any information. So what he's going to do first is going to pour some water into the aluminum can. Oh, I take that back. He's pouring some cold water into a dish. And then this gentleman here is pouring a little bit of the water into this aluminum can. About a quarter cup or so. And now they're going to place it on the stove and turn the stove on. Now we're making observations of what's happening while it's being heated. Now it's hot, and they're going to flip it upside down, and this is what happens once you put it upside down into the cooler can of water, or cooler bowl of water. Okay. Now they're going to explain what's going on here, and we don't want to explain what's going on. And I'm going to give you just one more video to watch so we can see what happens after the water in the can before versus the water in the can after. Okay, so watch the second video here. Okay. So they're just pouring just a little bit of water in there. Okay, just a very little tiny bit, just so it's kind of hard to see the before here, but I swear there's so many interruptions here at home. Okay, again, heating it on the stove. And now it's been heating for a while. It's harder to see here what's going on during. That's why I showed you the other video. Now they're going to take the tongs and flip it upside down. Okay. And then pick it up out of there. And then you can see how much water was in there after. Literally, I think they put in maybe a couple tablespoons before, but you can kind of see just how much is draining out there. Okay. Okay, so that's the data that you want to look for. And then finally, you're going to complete the analysis section. Okay, so you're going to think about this. At the very beginning, when you put water into the empty can, was it really empty? So think about all the states of matter here. Was it really empty or wasn't it empty? If it wasn't empty, like empty being a vacuum, right? Then what was in it? When you started the activity, the can was open to the air outside the can. How did the air pressure inside the can compare to the air pressure outside the can? This is when you started. Was it equal, lower, or higher? Now think about the statement again. After we heat the can, we have expanding air inside the can, and some of it is leaving the can. Think about this in terms of numbers of air molecules inside and outside the can. So you're heating the can up, and there's water in the can that's liquid, right? And as you boil that water inside the can, some of that water liquid turns into water vapor. And some of the air that was in the can then gets pushed out of the can. So after heating the can, where are there more air molecules per unit volume, inside or outside the can? B, after heating the can, where are there fewer air molecules per unit volume, inside or outside the can? Okay, so think in terms of air pressure. If there's fewer air molecules, that would be lower pressure. So where is the lower pressure? Is it inside the can or outside the can? That would be for question B. And where's the higher pressure? Inside or outside for question A. The first few seconds after the can is inverted into the pan of water, the air inside the can cools rapidly. Where is the air pressure greater now? We just kind of talked about that, but we're looking at it in terms of numbers for number 3 and numbers of molecules and pressure for number 4. And then for question 5, at this point you inverted the can into the pan of water, preventing air from flowing in or out of the can. What was your observations? Okay. So then finally the conclusion section, based on your answers to questions 3, 4, and 5, above explain what happened to the can in terms of air pressure inside and the outside the can. Okay, so for this one, you may want to just, give yourself a little more space there and stuff like that. You could even, if you want to, attach like a picture, draw a picture of telling me what happens in that situation. I'm totally fine with you drawing a picture, taking a picture of your picture, and then attaching that for your conclusion. But make sure you put words in with your picture as well. But if you need a picture to help you explain, please, by all means, draw a picture. And then finally, go back to the resource website. At this site, read about how a mercury barometer works and look at the diagram of the mercury barometer at the top of the page. How is the can in the water, the can flipped over into the pan of water, similar to the mercury barometer? So think about a mercury barometer and how it is similar to flipping that can upside down in the pan of cooler water. Hopefully that explains what you need to do, and you guys have that video that you need for that portfolio. If you have any questions, let me know. Send me a webmail message and I will be happy to help you out. Have a great day, everyone.